Hello and welcome to this deep dive into the next evolutionary stage of artificial intelligence, titled The Architecture of Autonomy. For the past few years, our engagement with AI has been defined primarily by conversational interfaces, systems that wait for our input and then generate a single, impressive response. We are now standing at the threshold of a fundamental shift. We are moving beyond reactive large language models to building sophisticated, goal-directed agents. This transition is crucial for unlocking true enterprise value and solving complex, multi-step problems that existing conversational AI simply cannot handle. This presentation will serve as your blueprint, laying out the precise architectural components and operating principles required to understand and construct this new generation of intelligent systems. We will explore how we move from simple textual output to fully autonomous decision-making and action in the real world. Our goal is to provide a clear, technical, yet accessible map for navigating this transformation. The AI paradigm is fundamentally changing. We are actively moving from a world dominated by conversation to one driven by agency. For the last few years, the dominant metaphor for AI has been reactive and conversational, epitomized by systems like ChatGPT. They are brilliant, but they require continuous prompting and operate primarily within a single session boundary. Agency, on the other hand, is about building systems that proactively decide what to do next to achieve a defined goal. These agents formulate complex plans, identify and use external tools like APIs or databases, observe the outcomes of their actions, and crucially, they adjust their approach and strategy over periods spanning hours or even days, without needing constant human babysitting. This is not just a theoretical concept, it is already becoming a critical enterprise domain. Look at the figures on the screen. The projected size of the autonomous agents market is expected to hit a staggering $103.28 billion by 2034. Furthermore, Gartner predicts that by 2028, autonomous AI agents will be influencing 15% of all enterprise work decisions. This paradigm shift requires a new architectural mindset, moving past the simple chat interface to embrace complex, persistent autonomy. To make the concept of agency concrete, let us introduce Sarah, your autonomous colleague. We all understand how a competent human colleague works when given a complex task. If you ask Sarah to research Company X and give a recommendation by Friday, she does not just return a single text block like a chatbot. She initiates a multi-day, autonomous process, and we can map this process directly to the required architecture of an agent. Sarah first needs to clarify the goal. She asks questions about metrics, budget, and timeline. Once the goal is clearly defined, she forms a plan, breaking the large task into manageable sub-steps. The execute phase involves utilizing tools, such as pulling financials from internal databases or talking to the product team. If she hits a wall, for example, if key data is unavailable, she does not stop. She must adapt her strategy, perhaps by calling an expert or adjusting her plan based on past acquisitions context that she remembers. This entire loop of planning, acting, observing, and adjusting is continuous, allowing her to deliver a comprehensive recommendation by the deadline. This entire visual flowchart is the architectural blueprint of an agent, illustrating how decisions flow over time, supported by memory and tools. The distinction between a chatbot and an agent is perhaps the most important concept to internalize. A chatbot is a smart tool, capable of generating impressive text-based answers quickly. An agent, however, is a goal-oriented partner. Let us contrast their fundamental capabilities. A chatbot is reactive, responding only when prompted, and its knowledge is typically limited to its pre-trained data set. It answers based on general knowledge and generates text in a single shot. It cannot access real-time or private internal data, and it stops immediately when it hits a knowledge limitation. Sarah, the agent, operates differently. She is proactive. She starts by asking clarifying questions to scope the task. She uses tools to pull live internal data that is critical for the mission. She constructs and adheres to a multi-step plan. Crucially, when the agent encounters an obstacle or hits a knowledge wall, she adapts her strategy, reroutes, and continues working. She maintains a defined goal over multiple days or weeks. Ultimately, the difference is simple. A chatbot is reactive, focused on text output. An agent is goal-directed, focused on action and outcome. The foundation, or the formula, for agency begins with a critical architectural coupling, the large language model plus tool use. On its own, the LLM is a phenomenal reasoning engine, but it is trapped within its own neural network. It can reason perfectly, but it cannot perform a single action in the external world. The tool is the bridge to the real world. A tool can be an API call, a database query, or a web search function. The magic, the key ingredient that creates agency, happens when the LLM gains the ability to decide autonomously when, how, and why to use a tool. Look at the example below. Before tool use, when asked for the current stock price, the LLM is stumped. It hits a knowledge cutoff. After integrating the tool, the LLM applies its reasoning power to decide, I should use the get stock price tool. It then formulates the proper function call with the necessary parameters, executes that call through the tool, receives the real-time data back, the stock price, and then uses that fresh information to formulate its final, accurate response. This ability to reason, self-generate a function call, execute it externally, and integrate the result is the fundamental mechanism that creates basic agency. Building a fully autonomous agent is not achieved in a single step. It is a layered architectural process. We evolve the system from a bare large language model by incrementally adding capabilities, thereby increasing its level of autonomy. It is essential to recognize that not every use case requires all 5 layers. The art of agent design lies in determining which layers are necessary for the job. At the foundation is the bare LLM, which simply generates text based on its training data. The first step toward agency is adding tools, granting basic agency by enabling access to real-time data and basic actions. The next layer is planning, granting multi-step agency by allowing the agent to break down a high-level goal into a sequence of smaller subtasks. Above that, we add memory, which enables contextual autonomy. Memory allows the agent to maintain context across many conversations and, more importantly, learn from all past interactions. The final layer consists of feedback loops, which grant full autonomy. This mechanism allows the agent to observe the outcome of its actions, self-correct when errors occur, and continuously improve its performance over time. This layered view demonstrates that autonomy is a spectrum, not a switch. A complete, fully functional agent architecture operates on a continuous 4-phase loop, which is the core engine enabling autonomous and adaptive behavior. This is known as the Perceive Plan Act Feedback Loop, or PPAF. This loop governs how the agent thinks, acts, and learns perpetually. The cycle begins with perception, which we can call the senses. The agent gathers necessary data, inputs, goals from the user, context from the environment, and crucial information from its own persistent memory. Once the context is set, the process moves to planning, which is the brain. Here, the LLM's powerful reasoning is applied to decompose the high-level goal, form a concrete strategy, and decide the precise next action required. Following the decision, we move to action, which represents the hands. This phase involves the agent executing the plan by calling external functions, tools, APIs, or any other defined mechanism to interact with the external world and make changes. Finally, the loop closes with feedback, the mirror. The agent observes the outcome of the action just taken, evaluates whether it was a success or a failure against the goal, and uses that observation to update both its plan and its memory, starting the cycle anew. This continuous, self-correcting loop is what defines true autonomy. In the enterprise, organizations frequently confuse key concepts surrounding automated intelligence. Understanding the difference between chatbots, tools, workflows, and agents, and their distinct architectures is crucial for selecting the right solution for the right problem. Let us review the primary differences using this comparison table. If your primary need is a simple conversational response, a chatbot is the answer. If you need specialized task execution, use an AI tool. For predefined process automation and consistency, use a workflow system. But if you need autonomous goal pursuit, you require an agent. Autonomy level varies significantly. Chatbots are reactive, waiting for a prompt. Tools are user-driven. Workflows are trigger-based. Only agents are proactive and goal-directed. Adaptability follows this trend. Agents are high in adaptability because they learn from feedback and errors, whereas the others are none, being either pattern-based or rule-based. The state difference is also vital. Agents maintain persistent state and memory across interactions. The others are mostly stateless or only stateful within a single run. Finally, the decision logic for agents is LLM-based reasoning, giving them the flexibility to strategize, compared to the intent matching or predefined rules used by the other systems. Choosing the right architecture prevents costly overengineering. To illustrate the power and return on investment of agent architecture, let us look at real-world missions. Our first mission is autonomous sales qualification. The problem is a massive bottleneck. A sales development rep, or SDR, spends 15 to 20 hours every single week manually reviewing and qualifying hundreds of inbound leads. We can apply the PPAF loop to this task. The agent perceives a new lead arriving in the CRM. It then plans by analyzing that lead against the ideal customer profile, determining its quality score and fit. The agent then acts by sending a personalized email, utilizing a messaging tool. Finally, it provides feedback by monitoring the lead's engagement with that email and updating its qualification score. The payoff, the return on investment, is dramatic and immediate. Enterprises see a 60 to 70% reduction in SDR time spent purely on qualification, freeing up human staff for actual selling. This translates directly to 40 to 50% more leads being qualified per month, and a notable 20 to 30% improvement in qualification accuracy because the agent is consistent and rule-bound. Our second mission focuses on autonomous market and competitive research, a perfect example of agent-driven knowledge work. Product managers often face a time sink, spending 20 to 30 hours each quarter manually gathering disparate data from websites, reports, and interviews just to synthesize a competitive analysis memo. This manual work is slow, inconsistent, and often out of date by the time it is finished. The agent solution applies the loop to this complex research task. It perceives the goal to analyze all competitors. It plans by decomposing the vast research effort into a sequence of small, manageable subtasks, such as finding specific reports or checking pricing models. It acts by using specialized web and database tools to extract the necessary information. Critically, the feedback loop is used to find alternative data sources if the primary sources fail or are unavailable, ensuring robustness. The ROI is profound. A massive 75% reduction in time spent on market research. This speed enables more frequent updates, changing the cycle from quarterly to monthly, and ensures the analysis is more comprehensive because the agent consults significantly more sources than a single human could manage in the same timeframe. Our third mission tackles autonomous customer service and resolution, an area ripe for immediate efficiency gains. Support teams struggle with high volumes of tickets, often requiring diagnoses across multiple legacy systems, resulting in a poor customer experience and an average resolution time spanning 24 to 48 hours. The agent can take ownership of the resolution goal. The process begins with perception, a new ticket, such as order not received. The agent then plans by diagnosing the root cause across various inventory, logistics, and billing systems simultaneously. It acts by using tools to query those systems or to process a refund if the root cause is determined. The critical feedback mechanism dictates that the agent escalates to a human only if the issue remains unresolved after exhausting its available tools and plans. The financial payoff here is transformative. We see 60 to 70% of tickets being resolved completely without human intervention. The first resolution time is drastically cut from 24 to 48 hours down to an impressive 15 to 30 minutes, leading to a 3 to 4 times increase in overall support team productivity and customer satisfaction. The consensus among leading firms and researchers today is clear. The agentic AI landscape is here, but the execution is the challenge. As noted by Deloitte consultants, building agent prototypes is relatively easy, thanks to the accessibility of LLMs and frameworks. However, running them reliably, safely, and cost-effectively at scale is where organizations truly struggle. The market adoption graphic highlights this reality. Only 11% of organizations currently have agents in production, while 62% are actively experimenting. To facilitate this experimentation and eventual production, several key frameworks have emerged, including LangChain, AutoGen, CrewAI, and tools from OpenAI, which provide the scaffolding necessary for constructing the PPAF loop. However, moving from experiment to production requires overcoming significant primary challenges. These include ensuring reliability, as agents can still hallucinate or take undesirable actions. Safety and governance are paramount to controlling autonomous behavior. Cost and latency need careful management, as sequential reasoning and tool calls are expensive. Finally, robust integration with legacy systems and sophisticated monitoring systems are mandatory for observability and compliance. Let us summarize the essential takeaways with 5 core concepts designed to ground your understanding of agent architecture. First, the fundamental shift is that agents are goal-directed, not reactive. An agent pursues a long-term objective even when you are not actively prompting it, distinguishing it from all prior conversational AI. Second, agency is layered. Autonomy is a spectrum built incrementally from components: the LLM, tools, planning mechanisms, memory stores, and critical feedback loops. You choose the right layers for the job. Third, the loop is the engine. The perceive, plan, act feedback cycle is the single, fundamental operating process that powers all autonomous, adaptive behavior in agents. Fourth, it is vital to choose the right architecture for the task. Optimize for the correct goal. Use chatbots for simple conversation, workflows for strict consistency and automation, and agents only when you require true autonomy and complex adaptability. Finally, remember that running agents is the hard part. The primary challenge is not the initial prototype construction, but the subsequent engineering effort required to run that agent safely, reliably, and cost-effectively in a regulated production environment at scale. You now have the comprehensive architectural blueprint for the next generation of intelligent systems. The rest of the journey, the transition from theory to widespread enterprise value, is engineering. Agentic AI is not some mystical concept. It is a pragmatic set of architectural principles that includes perception, planning, robust tool use, continuous feedback, and machine learning, all combined to create autonomous, goal-directed behavior. This foundational understanding allows you to move forward confidently. You can now build, strategically deploy, or effectively evaluate complex agentic AI systems within your own organization, knowing exactly what components are required for scalable and reliable operation. Looking ahead, in upcoming chapters or sessions, we will dive much deeper into the practical implementation details, exploring topics like advanced multi-agent architectures, where different agents collaborate on a single mission, and detailing the critical steps required for achieving true production readiness and security. To continue your journey into the architecture and engineering of autonomous agents, we have compiled a list of further reading and resources. These references fall into 3 critical categories. First, the foundational papers provide the intellectual groundwork that all current agent architectures are built upon. This includes the highly influential ReACT, synergizing reasoning and acting in language models, and the essential work on tool use in large language models, both of which define the integration of reasoning and action. Second, we recommend consulting the framework documentation for the leading construction tools in the space, such as LangChain and LangGraph, AutoGen, and CrewAI, which you will use to implement the PPAF loop in code. Third, stay informed on the market and enterprise trends by reviewing the key industry reports, including the McKinsey State of AI 2025, the Gartner AI Agents Top Tech Trend for 2025, and the latest Deloitte AI Adoption Survey 2025. These resources will bridge the gap between architectural theory and practical implementation strategy.